Okay, so welcome back. So on the previous video, we have seen the principle of increasing entropy, which basically we say that the total change of the entropy of the universe will be equal to the change of the entropy of the system plus the change of entropy of the surrounding. Okay, and in most cases the change of entropy of the universe is equal to the change of entropy of the system plus delta Q over T, which is the change of entropy with the surrounding. Alright, so we're going to see what happened with this equation for closed system and open systems. But before we go to that step, just remember that the total change of entropy of the universe is always positive or equal to 0. So if it's equal to 0, the process is reversible, and if it's higher than 0, it is irreversible. So let's first look at what happens with closed systems. So closed systems, the most common case is the one of the pistons in the assembly, or the one of an enclosed box or container. So this is your closed system, this is your closed system, and basically we say the way to recognize a closed system is that the mass is constant. Okay, so for these systems we had the first equation of thermodynamics was equal to Q minus this, and if we neglect kinetic and potential energy, we had equal to delta U. Alright, so the total change of entropy for the system, for the universe, will be equal to change of entropy of the system plus delta Q over T. So the change of entropy for the system will be equal to the mass of substance in the system, S final minus S initial, plus now this is the part that is a little bit complicated. Not complicated, but you need to understand. So if you put heat, let's say, in the system, what is that going to do? Is it going to increase or decrease the entropy? So basically what you need to think is at the definition of entropy. So the definition of entropy is a measure of how well you are using the energy. So if somebody puts energy inside, it helps that you will be using in a better way your energy. So actually what's going to happen is that if this is into the system, the entropy decreases, because basically it means that somebody is helping you to lose less energy. Okay, so you will have here delta Q over T. So if delta Q goes inside the system, entropy decreases. Now if delta Q is out of the system, what does that mean? That you are losing more energy. So entropy increases that you cannot recover. Okay, So we'll do that with an example later on. And now for what I like to call open system, but in most textbooks they are called control volume systems. In this case, you will be dealing with the systems that have a mass flow. So this is over here your control volume. And basically, that's why they call it control volume, because this is under control and you have mass flowing. Okay? So in that case, we know that the first principle of thermodynamics, you can write it as Q dot minus power, and if we neglect kinetic and potential energy, what was the difference? In most cases, it will be equal to the change in enthalpy. So in this case, the change of entropy of the universe is equal to the system plus delta Q over T. And this will be equal to what? This time, instead of M, will be what? M dot S final minus S initial plus delta Q over T. Okay? So this will be the end of this video. But again, be careful with this one, because as you can see, generally the heat going in is positive. So people have a tendency to add this term. But really what it's going to do is decrease it. Okay? So be careful with that.